check and make sure this is rolling, because that would be horrible if it wasn't. Okay, yeah, we are rolling. So, I'm going to pick up on your homework here. This is we're going to start, we're talking about number 5 under the AC circuit transformers induction homework. And number 5 is about AC voltage. Right? You know, because it even mentions the word RMS. So it says the RMS voltage is 120 volts. Right? And they're talking about the voltage of these power outlets here. What is the peak voltage? Right? So the max, or the peak, is equal to square root of 2 times the RMS. Right? So just take your RMS voltage, put it here, multiply by root 2. You'll get a number. It says that, let's see, a light bulb is rated at 175 watts. In my example, yours might be different. This is a power. And the formulas for power. Current times voltage, there's one. I squared times R, there's another. Voltage squared over resistance, there's another. Probably can use any of these to solve it. I probably would start here. Put the power here. Put your RMS voltage here. That's important. You don't put peaks in. The peaks really are not relevant. The only thing that matters are RMS values. So anytime you do power calculations, you want to use RMS values. So put your RMS voltage here, you'll be able to get the current. Then from Ohm's law, V equals IR. Take your current, put it here. Take your voltage, 120 volts, put it here. You can calculate the resistance. I'll let you look at part C and decide. If you don't get that figured out, ask and I'll respond how to do that on the forum. All right, so number 6, there's a picture. Let me get that picture drawn. All right, so we have an AC voltage, which is 120 volts. That's the standard voltage of the U.S. power grid. Then we have a light bulb, which I'm going to represent with a resistor. Another light bulb. Another light bulb. So again, what I'm doing here is I'm drawing a circuit diagram. I made a video about how to draw circuit diagrams. You have a voltage symbol. Now the voltage can be this symbol or this symbol, depending on whether it's a DC voltage like a battery or an AC voltage like those outlets. In this example, it's an AC voltage. So this symbol is basically taking the place of this. Okay. These are resistors. Light bulbs have resistance to them, so I'm representing the light bulbs in my circuit diagram with these resistors. Now, lamps 1 and 2 are 60 watts, and the other one is 25 watts. So in my example, this is a 60 watter, another 60 watter, and a 25 watter. Yours may be different. Now, those are not resistances, those are wattages. And, remember that I used to color code those in the videos? You can do the same thing here. This would all be one potential because this is all conducting material. Remember the I facts. One of the very important I facts was no electric fields in conductors, so the conductor itself is an equipotential. Now remember, in the picture, these are all wires made of aluminum or copper or some conductor. So this blue is all one potential. So blue to black, 120 volts. Blue to black, 120 volts, 120 volts, 120 volts. So it's 120 volts across every one of these. Now, let's see, what we want to do is calculate currents. So power, right, is equal to I times V, current times voltage, also equal to I squared R, also equal to voltage squared over R. These are the 3 ways power can be calculated. You probably only need one for most of these problems. I would start here. Put the 60 watts here. This is ran off a blue to black, 120 volt potential, so that would be this number. That's how you find the current. And you do that same thing for this bulb and this bulb. Once you know the current, let's see. Part B says find the resistances. Well, there's a couple ways to do that. Take the 60 watts, put it there under power. Take the current you calculated, put it there. Don't forget it's squared. You can calculate the resistance like that. You can also get it from Ohm's law. V equals IR, remember? So going back to this resistor, I can take the 120 volts, put that value there. Remember, you calculated the current for part A for each bulb, so you can put your current there and find the resistance out. Either one will get that done. Let's see. The next one, a step-down transformer. Yeah, most of these are now transformer problems. So I would start with a schematic of a transformer. And that's what this is, right? Iron core, wraps, right? N1, and AC voltage in, right? Number of wraps on the other side, and AC voltage out. The big thing about the transformer is this, what it's used for. It's used to change voltage up or down. The output voltage is equal to N2 over N1 times the input voltage. So in number 7, it says a step-down transformer. So this is a transformer that's used to drop voltage. Mine says the turn ratio, N2 over N1, is 7.24. They mean 7 over 24. So in my example, the output voltage is equal to N2 over N1 is 7 over 24. This was given in the problem. Yours is probably 2. It may not be 7 over 24. It might be some other ratio. It says it's used with 120 volt voltage. That's the input of the transformer. All right, 120 volts. And then just calculate the output voltage. Let's see. Calculate the power delivered to the CD player. So they give you a voltage in, 120 volts. This was given in the problem. Mine gives a current in, and the current that I'm given is 375 MA. That stands for milliamp. So that's 0.375 amps. When you calculate the power in, that's going to be current times voltage. In my example, that'd be 0.375 amps times 120 volts. This is going to be some number. Yours is going to be not the same number, but that's how you're going to calculate it. I think what I'm going to do is stop because I've got other things to do this morning. I'll probably make one more hopefully later today, talk about 8, 9, and 10. And hopefully we'll all be in great shape.